Hello guys, hope you all are doing well. So today we are going to discuss a perovskite solar cell. It is a journal presentation on perovskite solar cell. So let's start our presentation. So here the content we'll be discussing is the energy resources, basic structure of solar cells, generation of solar cells, perovskite structure, classification of perovskites, and advantages and disadvantages of perovskite. So as we know, we have energy resources, the renewable energy resources and non-renewable energy resources is solar energy, hydro energy, wind, biomass, tidal energy. These are the sources, renewable energy resources, while nuclear, petroleum, natural gas, coal, these are non-renewable energy resources. As we know that renewable energy sources, we use them again and again, while non-renewable energy resources we can't use them again and again, and we can't use them directly. Also they are limited, while renewable energy resources are unlimited. So that's why we are here focusing on solar energy. So let's start our presentation. So the solar energy, we use solar energy through a device known as a solar cell. So the basic structure of solar cell is made up of three components. So that is the light absorber, carrier collector and metal contact. So the light absorber convert the incident photon to electron and a hole, while the carrier collector captured the carriers, that is the electron and hole. So after that we will discuss the metal contact. So the metal contact transfer carriers towards electrode. So the heart of solar cell is the absorber layer, that is the quantum dot, perovskites, organic dye, etc. These are the absorber layer. We use them in solar cell. So there are three generation of solar cells: first generation solar cells, second generation solar cells, and then third generation solar cells. As we know that single crystal silicon are the first generation solar cells. They are the most efficient solar cell till date, and we are using them. But the cost of and the fabrication method of these solar cells are too much expensive, so everyone can't afford them. So that's why we replace the first generation solar cell by second generation solar cell, that is the amorphous silicon, etc. And also second generation solar cell were replaced by the third generation solar cell. The reason behind that they were flexible, the fabrication method and the cost was also normal, or can say less. They are less expensive, but they are not much efficient as that third generation solar cell. So here we are focusing on perovskite solar cells. So perovskite solar cell is a third generation solar cells. So organic solar cell, perovskite solar cells, quantum dot solar cells, these are the third generation solar cells. So here we are focusing on perovskite solar cell. So before going towards the perovskite solar cell, we all should know about what is perovskite. So it was discovered in mountains in 1839 by a Russian scientist. Material with the same type of crystal structure as that of calcium titanate were known as the perovskite material. So let's start the perovskite structure. Perovskite have general formula ABX3, where A is a large cation, B is a small cation, and X is a halogen anion. So large cation A is located in the vertex of face-centered cubic lattice. As you can see, the large cation on the vertex of face-centered cubic lattice, while the small metal cation B is in the center. So you can see it halogen X, then we can use them as a chlorine, bromine, or iodine, or oxygen, that is located on the face centered. So it is located on the face centered. So the metal halogens octahedra are joined together to form a stable three-dimension network structure, where A cation are short organic cations, that is MAFA, are inorganic cesium. So the B site is typically occupied by either lead, tin, or germanium. Halogens anion are chlorine, bromine, iodine, or oxygen. So let's move toward the next slide. So distortion. Most perovskites are distorted and do not have the ideal cubic structure. Some distortion may exist in the ideal cubic form of perovskite, resulted in orthorhombic, rhombohedral, hexagonal, and tetragonal form. So the reason behind this distortion,
is due to the difference in the sizes between the cation on A and B side. As we know that A is a large cation and B is a small cation, so due to which the sizes of these cation are different. So due to these difference in sizes, the perovskites do not have ideal crystal structure. So these distortion play a very vital role in the properties of material. So the tolerance factor link the difference in the cation size in the structure. If the distortion can control specific property, can target it. So here we can find the structure through the tolerance factor. So the formula for tolerance factor is equal to radius of A cation plus radius of halogens divided by under root 2 into radius of p cation plus radius of halogens. So from tolerance factor we can find the structure of perovskite. If the tolerance factor value is greater than 1, then the structure will be hexagonal. If it lies between 0.9 to 1, then it will be cubic. And if these are the ranges and which shows the different structure of perovskites. So, and the example, if the tolerance factor is greater than 1, then the structure will be hexagonal, A ion too big or B ion too small. So, the example of this perovskite is barium titanate. So, this is a table you can see and can find the structure and with example. So let's move toward the next slide. So perovskite are classified into inorganic oxide perovskite and halide perovskite. So due to the presence of oxides present in this perovskite, so we can't use them for solar purposes, solar energy purposes, because it is present these inorganic oxide perovskite have ferroelectric properties, due to which we can't use them in solar cell because they don't have the ability to absorb light. So for that reason we are just focusing halide perovskite, that is AMX3. So then they are classified into alkali halide perovskite and organometal halide perovskite. So why perovskite solar cells? So these are the advantages and limitations of perovskite solar cells. So advantages of perovskite solar cell is the easy, because it is easy to fabricate, excellent light absorption, availability, tunable bandgap, high power conversion efficiency, and energy payback time of just a few months. So the disadvantages or the drawback or the limitation of perovskite solar cells are the lead compound are very toxic and harmful to the environment. It is toxic to the central nervous system, especially in children. Lead perovskite are also unstable when exposed to moisture, heat, or UV radiation, mean it is too sensitive toward light. So the development of eco-friendly lead-free perovskite material is highly desired to produce the next generation solar cells. So this was the journal presentation on perovskite solar cells. It was the first step. So in this presentation we just discussed the perovskites and the generation of solar cell. In the next video we will discuss perovskite solar cells. Hopefully you guys understand it, and thank you so much for watching my video. Kindly share and subscribe our YouTube channel. Thank you.